Dear students, in this session, we are going to identify the purposes, features and functions of the following network components. Network components are hubs, switches, bridges, routers, gateways, CSU and DSUs, that is channel service units and data service unit, NICs, that is network interface card, ISDN, that is integrated services digital network adapters, WAPs, that is wireless access point. All but the most basic of networks require these devices to provide connectivity and functionality. Understanding how these networking devices operate and identifying the functions they perform are essential skills for any network administrator and requirements for a network candidate. This lecture introduces commonly used networking devices these days. We will discuss each one in detail. Hubs. At the bottom of the networking chain, hubs are used in networks that use twisted pair cabling to connect devices. Hubs can also be joined together to create larger networks. Hubs are simple devices that direct data packets to all devices connected to the hub, regardless of whether the data package is destined for the device. This makes them inefficient devices and can create a performance bottleneck on busy networks. In its most basic form, a hub does nothing except provide a pathway for the electrical signals to travel along. Such a device is called a passive hub. Far more common nowadays is an active hub, which as well as providing a path for the data signals, regenerates the signals before it forwards it to all of the connected devices. A hub does not perform any processing on the data that it forwards, nor does it perform any error checking. Hubs come in a variety of shapes and sizes. Small hubs with 5 or 8 connection ports are commonly referred to as work group hubs. Other can accommodate larger number of devices, normally up to 32. These are referred to as high density devices. Because hubs do not perform any processing, they do little except enable communication between connected devices. For today's high demand network applications, something with a little more intelligence is required. That is where switches comes in. Like hubs, switches are the connectivity points of an Ethernet network. Devices connect to switches via twisted pair cabling, one cable for each device. The difference between hubs and switches is in how the devices deals with the data that they receive. Whereas a hub forwards the data it receives to all the ports on the device. A switch forwards it only to the port that connects to the destination device. It does this by learning the MAC address of the devices attached to it and then by matching the destination MAC address in the data it receives. By forwarding data only to the connection that should receive it, the switch can improve network performance in two ways. First, by creating a direct path between two devices and controlling their communication. It can greatly reduce the number of collisions on the network. As you might recall, collisions occur on Ethernet networks when two devices attempt to transmit at exactly the same time. In addition, the lack of collisions enables switches to communicate with devices in full duplex mode. In a full duplex configuration, devices can send and receive data from the switch at the same time. Contrast to this with half duplex communication, in which communication can occur in only one direction at a time. Full duplex transmission speeds are double that of standard half duplex connection. The net result of these measures is that switches can offer significant performance improvements over hub based networks, particularly when network use is high. Irrespective of whether a connection is at full or half duplex, the method of switching dictates how the switch deals with the data it receives. Explanation of each method is as follows. Cut through. In a cut through switching environment, the packet begins to be forwarded as soon as it is received. This method is very fast, but creates the possibility of errors being propagated through the networks as there is no error checking. Store and forward. Unlike cut through, in a store and forward switching environment, the entire packet is received and error checked before being forwarded. The upside of this method is that errors are not propagated through the network. The downside is that the error checking process takes a relatively long time, and store and forward switching is considerably slower as a result. Fragment free. To take advantage of the error checking of store and forward switching, but still offer performance levels nearing that of cut through switching, fragment free switching can be used. In a fragment free switching environment, enough of the packet is read so that the switch can determine whether the packet has been involved in a collision. As soon as the collision status has been determined, the packet is forwarded. Bridges are used to divide larger networks into smaller sections. They do this by sitting between two physical network segments and managing the flow of data between the two. By looking at the MAC address of the devices connected to each segment, bridges can elect to forward the data if they believe that the destination address is on another interface, or block it from crossing when bridges were introduced. The MAC addresses of the devices on the connected networks had to be entered manually, a time consuming process that had plenty of opportunity for error. Today, almost all bridges can build a list of the MAC addresses on an interface by watching the traffic on the network. Such devices are called learning bridges because of this functionality. Three types of bridges are used in network. Transparent bridge derives its name from the fact that the device on the network are unaware of its existence. A transparent bridge does nothing except block or forward data based on the MAC address. Source root bridge. It is used in token ring networks. The source root bridge derives its name from the fact that the entire path that the packet is to take through the network is embedded within the packet. Translational bridge. It is used to convert one networking data format to another, for example, from token ring to Ethernet and vice versa. Today, bridges are slowly but surely falling out of favor. Ethernet switches offer similar functionality. They can provide logical divisions or segments in the network. In fact, switches are sometimes referred to as multi-port bridges because of the way they operate. In a common configuration, routers are used to create larger networks by joining two network segments, such as a SOHO router used to connect a user to the internet. A router can be a dedicated hardware device or a computer system with more than one network interface and the appropriate routing software. All modern network operating systems include the functionality to act as a router. A router derives its name from the fact that it can route data it receives from one network onto another. When a router receives a packet of data, it reads the header of the packet to determine the destination address. Once it has determined the address, it looks in its routing table to determine whether it knows how to reach the destination, and if it does, it forwards the packet to the next hop on the route. The next hop might be the final destination, or it might be another router. Gateways. Any device that translates one data format to another is called a gateway. Some example of gateways include a router that translates data from one network protocol to another, a bridge that converts between two networking systems, and a software application that converts between two dissimilar formats. The key point about a gateway is that only the data format is translated, not the data itself. In many cases, the gateway functionality is incorporated into another device. Network cards. Network cards, also called network interface cards, are devices that enable computers to connect to the network. When specifying or installing at NIC, you must consider the following issues. System bus compatibility. If the network interface you are installing is an internal device, bus compatibility must be verified. The most common bus system in use is Peripheral Component Interconnect, that is PCI bus. but some older systems might still use ISA, that is industry standard architecture expansion cards. System resources. Network cards, like other devices, needs IRQ and memory input output addresses. If the network cards does not operate correctly after installation, there might be a device conflict. Media compatibility. Today, the assumption is that networks use twisted pair cabling. So, if you need a card for coaxial or fiber optic connections, you must specify this. Wireless network cards are also available. Even more than the assumption you are using twisted pair cabling is that the networking system being used is Ethernet. If you require a card for another networking system such as token ring, this must be specified when you order. To install or configure a network interface, you will need drivers of the device and might need to configure it. Although many devices are now plug and play, most network cards are now software configured. Many of these software configuration utilities also include testing capabilities. The drivers and software configuration utilities supplied with the cards are often not the latest available. So, it is best practice to log on to the internet and download the latest drivers and associated softwares. Integrated Services Digital Network is a remote access and WAN technology that can be used in place of a plain old telephone service, that is POTS dial-up link if it is available. The availability of ISDN depends on whether your local telecommunications service partner offers the service, the quality of the line to your premises, and your proximity to the provider's location. ISDN offers greater speeds than a modem and can also pick and drop the line considerably faster. If ISDN is available and you do elect to use it, a special device called an ISDN terminal adapter is needed to connect to the line. ISDN terminal adapter can be add-in expansion cards, external devices that connect to the serial port of the system, or specialized interfaces built into routers or other networking equipments. The ISDN terminal adapter is necessary because although it uses digital signals, the signals are formatted differently from those used on a LAN. In addition, ISDN can create multiple communication channels on a single line. Today, ISDN is not widely deployed and has been replaced by faster and often cheaper technologies. Wireless access point or APs are a transmitter and receiver, that is transceivers device used to create a wireless LAN or WLAN. APs or access points are typically a separate network device with a built-in antenna, transmitter and adapter. Access points use the wireless infrastructure network mode to provide a connection point between WLANs and a wired Ethernet lane. AP, that is access point, also typically have several ports allowing a way to expand the network to support additional clients. Depending on the size of the network, one or more APs might be required. Additional APs are used to allow access to more wireless clients and to expand the range of the wireless network. Each AP is limited by a transmissions range. The distance a client can be from a AP or access point and still get a usable signal. The actual distance depends on the wireless standard being used and the obstructions and environmental conditions between the client and the AP. Saying that an AP or access point is used to extend a wired LAN to wireless clients does not give you a complete picture. A wireless AP today can provide different services in addition to just an access point. Today, the access point or APs might provide many ports that can be used to easily increase the size of the network. Systems can be added and removed from the network with no effect on other systems on the network. Also, many APs provide firewall capabilities and DHCP service. When they are hooked up, they will provide client systems with a private IP address and then prevent internet traffic from accessing client systems. So, in effect, the AP is a switch, a DHCP server, router and a firewall. APs or access points comes in all different shapes and size. Many are cheaper and designed strictly for home or small office use. Such APs have low powered antennas and limited expansion ports. Higher end APs or access points used for commercial purposes have very high powered antennas, enabling them to extend the range that the wireless signals can travel. The term transceiver does describe a separate network device, but it can also be technology built and embedded in devices such as network cards and modems. In a network environment, a transceiver gets its name from being both a transmitter and a receiver of signals, thus the name transceivers. Technically, on a LAN, the transceiver is responsible for placing signals onto the network media and also detecting incoming signals traveling through the same wire. Given the description of the function of a transceiver, it makes sense that technology would be found with network cards. Although transceivers are found in network cards, they can be external devices as well. Chip transceivers are small and are inserted into a system board or wired directly on a circuit board. Module transceivers are external to the network and are installed and function similarly to other computer peripherals, or they can function as standalone devices. There are many types of transceivers: RF transceivers, fiber optics transceivers, Ethernet transceivers, wireless transceivers or WAP transceivers and more. Though each of these media types are different, the function of the transceiver remains the same. Each type of the transceiver used has different characteristics, such as the number of ports available to connect to the network and whether full duplex communication is supported. Media converters are a technology that allows administrators to interconnect different media types, for example, twisted pair, fiber and thin or thick coaxial within an existing network. Using a media converter, it is possible to connect newer 100 Mbps gigabit Ethernet or ATM equipment to existing networks such as 10 base T or 100 base T. They can also be used in pairs to insert a fiber segment into copper networks to increase cabling distances and enhance immunity to electromagnetic interference, that is EMI. A channel service unit or digital service unit, sometimes called data service unit, is a device that converts the digital signal format used on LANs into one used on WANs. Such translation is necessary because the networking technologies used on WANs are different from those used on LANs. The CSU DSU sits between the LAN and the access point provided by the telecommunications company. Many router manufacturers are now incorporating CSU DSU functionality into their products. In this session, we have understood about the most basic of network devices required to provide connectivity and functionality. We have discussed the purposes, features and functions of the network components as shown: hubs, switches, bridges, routers, gateways, CSU, DSU, that is channel service units and data service unit, NICs, that is network interface card, ISDN, that is integrated services digital network adapters, WAPs, that is wireless access points.